Mervit, for very nice introductions. And again, many thanks, Dr. Suzanne, and all organizing committee for inviting me to share in this wonderful conference. And many thanks for Pfizer. إن شاء الله تعالى برضه عشان إحنا تقلبات النت، فإن شاء الله تعالى هنسمع الفيديو، وأنا تحت أمركم بعد إن شاء الله تعالى بعد المحاضرة لو في أي كومنتات. شكرا.
السلام عليكم. في البداية أحب أشكر الأستاذة دكتورة سوزان and all the organizing committee for inviting me to share in this great prestigious conference. And many thanks for Pfizer for inviting me to speak today on infection by multi-drug resistance gram-negative bacteria. What's new in our arsenals and what's in the pipeline? During my presentations, I will answer the following question. What is the multi-drug resistant pathogens? What are the risk factors for development of multi-drug resistant pathogens? What are the therapeutic options? And what are the therapeutic options in the pipeline? And finally, how to prevent development of drug resistance. Penicillin, the first antibiotic, was discovered by Alexander Fleming in 1928. Accidentally, when he came back from 2 weeks of vacations and found a green mold called Penicillium contaminated the petri dish in his lab and killed some bacteria later known as staph. This is the timeline for discovery of the different antibiotics, starting penicillin, followed by sulfonamide and then aminoglycoside, tetracyclines, macrolide. When we look, we found a rapid discovery of antibiotics. The period from 1950 إلى 1970 بيسموها the golden age of antibiotics. During this period, there is discovery of over 20 new class of antibiotics. While the period من 1970 ل 1980 there is a release of more than 60 antibiotics in the market. من 1987 لحد 2011 بيسموها the discovery void because the last group of antibiotics discovered كانت في 1987. So what are the mechanism of action of antibiotic? The antibiotic kills the bacteria, termed bactericidal. If the antibiotic inhibits the bacterial growth, it is termed bacteriostatic. And they work by different mechanisms of action. One of the important mechanisms of action is to inhibit the cell wall of the bacteria. And through this mechanism work the most important group of antibiotic, which is termed beta-lactam antibiotic. مين هم البيتا-lactam antibiotic? Penicillin group, cephalosporin, carbapenem, and monobactam. This is the famous group of antibiotic and most commonly used. All it can act by inhibition of the senses or function of the nucleic acid. It can inhibit the DNA like quinolone or inhibit the senses of folate like trimesoprim, sulfamesomazole, or it also can act through inhibition of the protein senses like macrolide, like aminoglycoside, and tetracycline. As we see here, there is a spread of the use of antibiotic even in the low and middle income countries. So what is the multi-drug resistant pathogen? World Health Organization defines the antimicrobial resistance as the ability of the microbe, bacteria, virus, or fungus to evade the action of antibiotic or antimicrobial agent. Most pathogenic microorganism has the ability to develop resistance to at least some antimicrobial agents. Resistant microbes are more difficult to treat, requiring alternative medication or higher dose of antimicrobials. This approach may be more expensive, more toxic, or both. The microbes that are resistant to multiple antibiotics are called multi-drug resistant. Those considered extensively drug resistant or pan drug resistant are sometimes called superbugs. So what are the multi-drug resistance? The multi-drug resistant microbe resistance to 3 or more class of antibiotic, while extreme resistance means resistant to 5 class of antibiotic or sensitive to only 2 antibiotic. Then drug resistance means non-sensitive to any agent of antibiotic. وفي 1917 لقوا ان السودوموناس ايريجينوزا resistant to all antibiotics, so we are facing serious problem. Resistance is not new. In 1945, with Nobel Prize lecture of Alexander Fleming himself, warned of the danger of resistance. He said it is not difficult to make the microbe resistant to penicillin in the laboratory by exposing them to concentration not sufficient to kill them. And the same thing has occasionally happened in our body through exposing the microbe to non-lethal quantities of the drug, which make them resistant. So antibiotic resistance is fact in our life. The resistance spread very rapidly. When we look to the methicillin-resistant strain, it is very low before 1980, and then spread very rapidly. The same for vancomycin-resistant Enterobacteriaceae. This is the carbapenem-resistant bacteria in the patient with hematological malignancy. It was found to endemic in areas, 13 areas of world. In Egypt, it is also high prevalence. Resistance varies widely. Also, carbapenem-resistant Klebsiella pneumoniae have high prevalence in Egypt, while lower in other areas of America or United States. World Health Organizations reported antimicrobial resistance as one of the most serious health threats worldwide. So, antimicrobial resistance is a nightmare that poses catastrophic threat to public health in every country in the world. CDC reported in 2013 the estimated number of infections with multi-drug resistant in the United States over 2 million and over 23,000 deaths every year from multi-drug resistance. And they reported the most serious organism reported is the Enterobacteriaceae, multi-drug resistant Pseudomonas, and Acinetobacter, while carbapenem-resistant Enterobacteriaceae is categorized as urgent need. في 2016 700,000 deaths worldwide، 50,000 منهم كانوا في Europe and the United States. It is expected in 2050 to find 10 million deaths every year worldwide, more than the death of cancer, of diabetes, or other infection. And this will cause total global cost of up to $100 billion. So what are the risk factors for this multi-drug resistance? Multifactorial. Environmental factor play a role. Physician-related factor also. Patient-related factor and drug-related factor. So what are the physician and the prescribed related factor? Overuse, misuse, inappropriate use of antibiotic may accelerate the development of drug resistance. And this very important paper published this year in 2021, where they found overuse, misuse of antibiotic the first risk factor for development of antibiotic resistance. Inadequate professional competence of healthcare physician might worsen the complication associated with antibiotic resistance. We all know viral infection not stopped by antibiotic, yet doctor still prescribe antibiotic to treat viral infection. This is a major abuse of antibiotic which can lead to development of drug resistance. Environmental factor, overcrowding is very important risk factor, like in the daycare centers. Also in oncology unit, in ICU, in dialysis unit, and with prolonged hospitalizations, risk factors. Another environmental risk factor is increasing national and international travel, which can enable a spread of resistance from area of endemicity to another area. Patient risk factor, multi-drug resistance, is more common with poor adherence of the dosage regimen. الدكتور يقعد يحسب الجرعه، دكتور الاطفال نقعد نحسب جرعه الانتيبيوتيك والفريكونسي، وبعدين البيشنت يروح مش تاخد small dose او once instead of every 8 hours. Lack of sanitation, recurrent urinary tract infections, immune suppression, neutropenic patient, diabetic patient, is a patient on steroid. All these are risk factors for development of drug resistance. So, if the patient take antibiotic, it kills the bacteria causing illness, as well as the good bacteria protecting the body from infections. The drug-resistant bacteria are now allowed to grow and take over. In addition, some bacteria can give their drug resistance to other bacteria, and this is termed transverse transmission. So the antibiotic resistance gene transferred between man, animal, and environment. If the antibiotic is given to the animal, drug resistance can develop, and this can present in the meat. لو في bad management of meat or improper cooking, it can transmit it to the infection, and the same from the infection to the environment. So what are the mechanisms of antibiotic resistance? The antibiotic must enter the bacteria in sufficient concentration, and then it acts at the site of infection. So the first mechanism of action is to decrease the entrance of the antibiotic to the bacteria. And the mechanism of this can act through the beta-lactam, decrease the expression of the core enzymes, or pumping the antibiotic outside, which is termed flux pump, or inactivating the antibiotic by secretion of enzymes like beta-lactamase or altering the target. So the antibiotic resistance can develop through prevention of antibiotic from entering, or pumping the antibiotic outside, or inactivating the antibiotic, or modifying the antibiotic target. So why antibiotic resistance is important? ليه احنا عمالين نهتم وندرس في هذا الانتيبيوتيك ريزيستنس؟ لانها it can lead to treatment failure, recurrent infection, longer hospital stay, in addition higher risk of mortality. وده بنشوفه كتير جدا في العيان الاميون كومبرومايزد بيشنت، ندي كل الانتيبيوتيك وستيل فيفر والعيان نوت ريسبوندينج. ليه؟ اللي بقى عنده bad drug resistance and can lead to this. It also can increase the financial cost of treatment. And this is very important study done to assess the mortality in the sensitive strain versus the resistant strain. واحنا لوك بس جاست هنا تو ذا كليبسيلا نيمونيا، هنلاقي ان الديس في السنسيتيف سترين 12.5، بينما الديس في الريزيستنت سترين حوالي 43-44، يعني up to a 4-fold higher mortality in the resistant strain than the sensitive strain. When we look to the discovery of antibiotic هنلاقي إن من 1983 ل 87 كان في discovery لحوالي 16 groups of antibiotic. And this discovery decreased with time بحيث إن في 2008 ل 2012 كان only 2 antibiotic. So the Infectious Disease Society of America make initiative called 10 multiplied by 20. He encouraged to develop new antibiotic, 10 new antibiotic by year 2020 to overcome this development of resistance by to treat. We have now more resistant strain and new antibiotic. And this is the decline of antibiotic with age, and with progress, only 5 novel antibiotics discovered in the last 20 years. When we look to this table, it is very important. This is the year of FDA approval of the antibiotic, and this is the first report of resistance. لو جينا على البنسلين approved في 1943 لكن الفيرست ريبورت اوف ريزيستنس كان في 1940. لو جينا بعد على الستريبتومايسين FDA approved في 1947 the first reported case of resistance in the same years 1947. لو جينا للميثيسيلين FDA approved 1961 كانت الفيرست reported case of resistance. The same for the third generation cephalosporin 1981 approval 81 development of resistance. This is the last new group of antibiotic discovery. لو احنا جينا على هذا السيفاترولين اللي هو the fifth cephalosporin group هو very effective against the MRSA. هنلاقي ان في عندنا دلوقتي سيفترولين resistant staph. بقى عندنا كمان كوليستين resistant Klebsiella pneumoniae. This is the most common multi-drug resistance. عندنا كلنا عارفين طبعا الستاف المرسا والفانكومايسين resistant staph، ولكن عندنا serious group developing now اللي هي multi-drug resistant جرام نيجاتيف بكتيريا. انتيروبكتريسي اللي هي بتشمل الايكولاي والانتيروباكتر والكليبسيلا نيمونيا، عندنا اسينيتوباكتر وعندنا سيدوموناس ايروجينوزا. So why we study gram-negative bacteria? Why we focus on the gram-negative bacteria? لأن gram-negative bacteria causes serious infection either in the community or the hospital. Can cause serious pneumonia, bloodstream infection, surgical infection, urinary tract infection. ودول الموست common gram-negative bacteria الإيكولاي والكليبسيلا والسيدوموناس والأسينيتوباكترس. However, antimicrobial resistant to gram-negative pathogens reached critical point with emergency of pathogen resistant to most of all available antibiotics. So it is nightmares. Several studies reported the mortality is higher in gram-negative bacteria with multi-drug resistance, and also the cost is higher with gram-negative bacteria, with antibiotic-resistant gram-negative bacteria. The gram-negative bacteria resistant leads also to poor outcome in the patient with hematological malignancy. When we look here to the E. coli, the mortality in the sensitive strain 7% only, while in the resistant strain 38%. What about the incidence? We have higher incidence of gram-negative bacteria, especially producing extended spectrum beta-lactamase, reaching up to 37%. So we have poor outcome with gram-negative bacteria, and with also higher incidence of gram-negative bacteria, especially the antibiotic-resistant strain. So the report from World Health Organization in 2017, it shows that multi-drug resistant gram-negative bacteria, Acinetobacter, Pseudomonas aeruginosa, and Enterobacter are critical for the health care, and also they need new drug to overcome this development of resistance. While the Infectious Disease Society of America lists 4 gram-negative bacteria as dangerous pathogens: Acinetobacter, E. coli, Klebsiella, and Pseudomonas aeruginosa. So what are the mechanisms of resistance to gram-negative bacteria? Like all bacteria, the same 4 mechanisms of resistance. But the most important is production of enzymes that break the beta-lactam ring or hydrolysis the beta-lactam ring, termed beta-lactamase. So what is the beta-lactamase? Beta-lactamase is a diverse group of enzymes collectively named beta-lactamase. It hydrolyzes the beta-lactam ring of of the beta-lactam antibiotic. What are the beta-lactam antibiotic? The most important group of antibiotic used in our practice: the penicillin, the cephalosporin, carbapenem, and the monobactam. So this diverse group of beta-lactamase hydrolysis, the beta-lactam, make the antibiotic ineffective. There are wide variety of beta-lactamase, classified by several mechanisms. One of these is Ampler classifications, either serine beta-lactamase class A. Class A beta-lactamase can include the extended spectrum beta-lactamase. This extended spectrum beta-lactamase hydrolysis penicillin, cephalosporin, monobactam, and only sensitive to carbapenem. This class C, which include the cephalosporinase. There is metallo-beta-lactamase, which is the serious because it causes hydrolysis to nearly all beta-lactam except the monobactam. This beta-lactam family, when we look to the class A included extended spectrum beta-lactamase, it included carbinase. When we look to the antibiotic which causes hydrolysis, we found the penicillin, cephalosporin. We found even with carbinase the carbapenem. The serious group, which is the metallo-beta-lactamase, it hydrolysis penicillin, cephalosporin, and also carbapenem. So there is no antibiotic can work with this group. This is very important table. When we look, this is the gram-negative pathogens. We have E. coli, Klebsiella pneumonia, Pseudomonas, and Enterobacteriaceae. This gram-negative bacteria causes serious infections in human. It causes urinary tract infections, intra-abdominal infection, bacteremia, and pneumonia. And this group producing variety of beta-lactamase, like extended spectrum beta-lactamase. This extended spectrum beta-lactamase hydrolysis, penicillin, cephalosporin, monobactam. So the only antibiotic effective here is the carbapenem. When we look to the Klebsiella pneumonia carbapenes, it hydrolyzes all beta-lactam. So there is no antibiotic effective. So we have serious problem. This beautiful review published by Logan in 2012, evaluating the carbapenem-resistant Enterobacteriaceae by the type and site. He found Klebsiella, E. coli, and Enterobacteria are highly prevalent and isolated from the blood, isolated from urine, from GIT and respiratory tract. And the most serious, they found this gram-negative bacteria resistant to ampicillin sulbactam, to piperacillin tazobactam, to trimesoprim sulfamethoxazole, and also to aminoglycoside with very high percent, and only sensitive to colistin and less than 20 resistant to tigecycline. So we have serious problem. How can we solve this serious problem? First, by new drugs, and the second, by prevention of development of multi-drug resistance. One of the important new drug developed is the ceftazidime avibactam, this novel combination. Ceftazidime, we all know, it is a third generation cephalosporin with anti-pseudomonal activity. And avibactam, it is the first non-beta-lactam beta-lactamase inhibitor. It inhibits a wide group of beta-lactamase. It can inhibit class A, class C, and some class D. What is the difference between avibactam and the other old beta-lactamase inhibitor? احنا عندنا clavionic acid, the beta-lactamase inhibitor, tazobactam, and sulbactam. The most important is have extended spectrum beta-lactamase inhibition. The second is the mechanism of inhibition is reversible. So the mechanism of action of ceftazidime, it acts as bactericidal as it inhibits the bacterial cell wall synthesis. And the avibactam, who are non-beta-lactam, beta-lactamase inhibitor, it binds to the enzymes to save the ceftazidime from hydrolysis by beta-lactamase. When we look to the difference between the avibactam with the old beta-lactamase inhibitor, clavulanic acid, and tazobactam. Class A, clavulanic acid mainly sensitive to some of class A beta-lactamase. Tazobactam sensitive mainly to class A and some of class D. When we look to avibactam, it is very important to inhibit all class A, class C, and some class D, but not effective against class B or metallo-beta-lactamase. What about the efficacy? This very important phase 2 randomized controlled trial done to assess the safety and efficacy of ceftazidime avibactam plus metronidazole in the treatment of children more than 3 months and less than 18 years with complicated intra-abdominal infections. What they found? They found ceftazidime avibactam plus metronidazole was well tolerated with safety profile similar to ceftazidime alone, and appeared effective in pediatric patients with complicated intra-abdominal infection due to gram-negative pathogen, including ceftazidime non-susceptible strain. Another important phase 2 randomized controlled trial evaluating safety and efficacy of ceftazidime avibactam in treatment of children more than 3 months and less than 18 years in the complicated urinary tract infections, where a group of the patient received ceftazidime and the other group received cefepime, which is the 4th generation cephalosporin. And they found ceftazidime avibactam well tolerated in the children with complicated urinary tract infections and with safety profile consistent with the adult with complicated urinary tract infections and ceftazidime alone, and appeared effective in children due to infection with gram-negative pathogen. So, ceftazidime avibactam can be used safely. It is approved in the adult في 2015 و FDA approved in pediatric في 2019 وإيما approved في 2018 to be used in hospital-acquired pneumonia, including ventilation-associated pneumonia, complicated intra-abdominal infection, complicated urinary tract infection, including pyelonephritis, in addition for treatment of infection due to aerobic gram-negative organism in the adult and pediatric aged 3 months or older with limited treatment option. So we are again in بعد 2000 عند حوالي 2013 there is again discovery of new drug of new antibiotic. And this is summary of the novel antibiotic approved by FDA and EMA after 2010. When we look, we found we have now ceftazoline tazobactam, we have now meropenem tavobactam, we have blasomycin, we have ravacycline. All of these group of antibiotics are effective against beta-lactamase producing gram-negative. But when we found to ceftazidime avibactam, we found it is more very good spectrum against the beta-lactamase producing gram-negative infection. So what are the new gram-negative what are the new antibiotic against the gram-negative in the pipeline? We have antibiotic in this phase 3 and antibiotic in the phase 1. One of the important antibiotic in the phase 3 is the cefidricol. This belongs to cephalosporin but has unique mechanism of action, and it is very, very effective against gram-negative pathogens, including Acinetobacter, including Pseudomonas aeruginosa, and including Klebsiella. They have also another important group of antibiotic like imipin, celastin, and another in the phase 2 and phase 1. So after we know all these serious complications of microbial resistance and limited treatment option, it is very important to stop development of antibiotic resistance. So what are the key preventive strategies? When look infections, when there is infection, we use antibiotic, and antibiotic can lead to development of resistance, and we have susceptible pathogens. How to prevent this cycle? First, by prevention of infection. Second, by effective diagnosis and treatment. Third, by optimize the use. And fourth, by prevention of transmission. How can we prevent infection? Through vaccinations and through removal of unnecessary device, and also infection control measure is very, very important. Diagnosis and treatment of infection, target the pathogens, access to the expert. Please, please, please use the antibiotic wisely. Practice the antibiotic control, use the local data. Treat infection and not contamination. Treat infection and not colonization. Know when to say no for Vanco. There is a specific indication for Vanco. So you use only with a specific indication. Stop treatment when infection is cured. Prevent transmission is very important. Surveillance is also very important to permit early detection of the resistant strain of public health importance. This will lead to improvement of the clinical therapy decision and also guide the policy recommendations. So we need multidisciplinary approach, depend on infectious disease specialist, infection control, clinical pharmacology, clinical microbiology, clinical also healthcare epidemiology. So my summary: misuse, overuse, inappropriate use of antibiotic contribute to antibiotic resistance. Antibiotic resistance, and particularly emergency of resistance to gram-negative bacteria, is one of the most significant healthcare issue facing the world today. Ceftazidime avibactam is new combination of antibiotic for treatment of the patient hospitalized with serious gram-negative infection, and it has been designed to manage some difficult to treat infections that are becoming increasingly recognized to the current standard of care. And thank you so much. I'm happy to take questions.
Many thanks, Professor Dr. Laila, for this comprehensive important